Alright, welcome back, Math1720. We are entering the last chapter in the book. Alright, we're going through Chapter 8, Section 1. We're going to cover complex numbers. You might know them as, like imaginary numbers or things like that. So we're going to get into, basic operations of them, adding, subtracting, multiplying, and dividing, and then being able to solve the ever so elusive quadratic equation that before your teacher's like, it's a negative number. We can't take the square root of a negative number. Well, that's not true because we can. And a lot of the calculations that we do in reality are actually based on complex numbers. There's a lot of calculations we do around electricity. We have real and imaginary power. I know that doesn't make sense, but that's exactly how it's transmitted. So there's just different portions of it. I don't expect you to understand that aspect, but let's go ahead and let's go through and start doing our calculations. Alright, so the first thing that you've seen before, most likely in Algebra 2, is I squared is equal to negative 1. So if we square root both sides, we get I is the square root of negative 1. So they're going to be interchangeable. Alright, so we're able to rewrite these. And sometimes we might have an I squared in a problem where we need to rewrite it as negative 1. Or we have the square root of negative 1, we got to write it as I. So we're just going to be doing some direct substitutions here with I squared and I. Alright, so if A and B are real numbers, any number in the form A plus BI, we consider that called a complex number. So A is the real part, B is the imaginary part. Alright, to that number. Later on, it'll have a polar coordinate, a magnitude, and a direction as well. So basic concepts here, alright? A plus BI equals C plus DI if A equals C, B equals D. Really, all that means is if the real part equals the real part and the imaginary part equals the imaginary part. If a number ceases to have an A, alright, so if A is 0 and there is a B value, the number is considered to be purely imaginary. So we would write it like example 3I. You could technically write that number as 0 plus 3I. The real part is 0. The imaginary part is 3I. If neither one of those are 0, so if A is some sort of real number, B is some sort of real number, we call that a non-real complex number. It's complex because it has a real part and an imaginary part. Alright, and it's non-real because it has the imaginary part. So the standard form for us with a complex number, we are always going to write it in A plus BI. Okay, that's our standard form for writing a complex number. So just remember, this is kind of the realm where complex numbers fit in. So we've been dealing with a lot of these numbers, most of your math career, all the way elementary school up through now. So it just kind of shows you where the real numbers are, where the complex numbers are, how they relate. Alright. So the first interchange that we're going to do, or substitution, like we talked about on like the second slide, is if we have the square root of a negative number, we can rewrite that as I square root of that number, because what we do is we write that as, we take that square root of negative A and we write it as the square root of negative 1 times the square root of A, and then we rewrite the square root of negative 1 as I. So that's really how we develop that expression here. Alright, so let's take a look at the first example here. We have the square root of negative 16. We should rewrite that as the square root of negative 1 times the square root of 16. Alright, or you can write it as the square root of 16, okay, times the square root of negative 1. You need to replace the square root of negative 1 with an I, and the square root of 16 is 4. So our solution is 4I when we work through this problem. Okay, 70, not necessarily a perfect square, but we can rewrite it, alright, as the square root of negative 1 times the square root of 70. So we factor out that negative 1. 70 is not necessarily, a perfect square, but we're able to rationalize it down if we need to, and so on and so forth. You can simplify it down. You got to look for other squares that build into it. But there's not really a lot of nice stuff. I mean, we get 35 and 2, but there's no perfect squares there. So, check yourself. Can you break that down? Is that number prime? If it's not prime, that means you can keep simplifying. If it's prime like Sunday or 70, you're going to always have to check and ask yourself, all right, can we break this down? Yes, we can break this down, or no, we can't break this down. We can't break down 70 into something multiplied times a perfect square. All right, let's look at the last example here. We have the square root of negative 48. So with that, you need to rewrite that as the square root of negative 1 times the square root of 48. Replace the square root of negative 1 with an I. And then you can simplify down 48 a little bit better. All right, as you go through, that becomes the square root of 16 times 3 there, right? So the square root of 16 breaks into 4. So we have 4 times I times square root of 3. If we simplify that down. All right, so rewrite everything separately. So when we're multiplying, different radicals, we can write them all separately under their own radical. Okay, so that's our rules of radicals. So the most simplified answer we can get is 4i square root of 3. Okay, now, these are the equations we really couldn't solve before, right? We got x squared equals negative 9. You're like, uh-oh, my teacher said I couldn't take the square root of a negative number. Now we can, all right? So we're going to have x squared equals negative 9. We're going to take the square root of both sides. Remember, there will still be two solutions. When you square root something in a calculation, you get plus or minus whatever that value is. So we're going to get plus or minus the square root of negative 9. You need to rewrite the square root of negative 9 as the square root of negative 1 times the square root of 9, and replace the square root of negative 1 with an I, and the square root of 9 is 3, so you'll have plus or minus 3i. Okay? So that's really how we break that one down. Okay, let's look at the next one. We got x squared plus 24 equals 0. So we're going to get that so that we can square root both sides. So you're going to get the x's on one side, the constants on the other, so that the example in part B starts out looking like the example does in part A. So we're going to subtract 24 from both sides. So we're going to get x squared minus 24. When we do that, then we're going to square root both sides. So when we do that, you're going to get x equals plus or minus, all right, square root of negative 24. And we're able to rewrite the square root of negative 24 as the square root of negative 1 times the square root of 24. That square root of negative 1 translates into an I. And then 24 does have a perfect square that's involved as a multiple. So we need to break that down into 4 times 6. Okay? Then that becomes the square root of I times the square root of 4 times the square root of 6. Square root of 4 is 2. So we end up with plus or minus 2i square roots of 6. Alright, so if we write both of these in solution sets, alright, because there's two answers, so that's why we write it as a solution set. So this one will be plus or minus 2i square root of 6. The first one will be plus or minus 3i. Alright, so, always try to have, a method to how you do it. So when you're working with negative radicals, okay, invoke the definition of the square root of negative 1 equals I before anything. So separate that. So what this really means is we're going to take the square root of negative a, that becomes the square root of negative 1 times the square root of a, and rewrite the square root of negative 1 as I before we do any other rules or anything like that. So get that negative 1 out of there in terms of I. Okay, especially when we have a rule something like this. Okay, and they're not negative numbers. It really will mess things up later on. Okay? Alright, so now we're going to multiply or divide. So, here's what happens when we simplify each answer. We have the square root of negative 7 times the square root of negative 7. This is what the caution was on the previous slide. Don't multiply those. It doesn't become the square root of 49. Okay, because it's not going to be negative 7 times negative 7. Get the i's out first. Okay, so when we do this, all right, you're going to get I square roots of 7 times I square roots of 7. We've taken out the negative part of the root. Okay, so when we do that, we're going to get I squared times the square root of 7 squared. That little box means multiplication, and I don't know why it's not showing up correctly on my slide. All right, remember we can rewrite I squared as negative 1. So every time we see the term I squared, we rewrite it as a negative 1. So this ends up being negative 1 times 7. So the answer here is negative 7. So just make sure that you do, as you're supposed to with this. Get rid of the negative under the radical first by translating it into an I outside of the radical. Alright, so let's look at example B. So don't multiply that and make that the square root of 60. Alright, it's not going to work that way. You have to take and make it so that it is square root of negative 1 times square root of 6 and square root of negative 1 times the square root of 10. Then turn those into i's. Okay, so you get I square roots of 6 times I square roots of 10. Now when we multiply this out, we get I squared times the square root of 60. Well, the square root of 60 you're going to have to break down and look for something that has a perfect square that goes into 60. Also, the I squared becomes negative 1. Alright, I squared times the square root of 4 times 15, and the square root of 4 is 2, so now we have an even square. So you're going to get 2I squared times the square root of 15, and then I squared we replace with negative 1, so this ultimately becomes negative 2 square roots of 15. The same rule is going to apply to us in part C, or example C, when we do division. Get the I out first. Alright, so rewrite the numerator as the square root of negative 1 times the square root of 20. Rewrite the denominator as the square root of negative 1 times the square root of 2. Alright, so that'll really help. And then we're going to end up with I over I. Alright, the i's will cancel, and we can actually do 20 divided by 2 since they're both under the square root, and be left with the square root of 10, and the square root of 10 is prime, and we would leave it as such. Okay, now do the next one. Only the top has a negative. So we got to start by replacing that negative with an I. So the top becomes negative square root of 1 times 48 divided by square root of 24. So that negative square root of 1 becomes an I. So we get I, times the square root of 48 divided by the square root of 24. You can rewrite that as one integrand, so it'll be, or not integrand, one radical. So it'll be I times the square root of 48 divided by 24. 48 goes evenly into, or 24 goes evenly into 48. Alright, twice, so the final answer in this scenario is I square roots of 2. Alright, so now we need to simplify a quadratic down, right? Before you might get a negative under the radical. So we have to take, kind of a separate approach and break that up. Alright, that'll actually help get us some values, and then we need to make sure that we end up in the standard form of real plus imaginary, so we're going to be complex here, right? So we're going to be a plus bi when we get this calculation here. Alright, so the first thing is handle the negative square root. Alright, so that ends up being I times the square root of 128, just that little section piece right there, okay? Then we have to find perfect squares for 128, okay? So you're going to get negative 8 plus the square root of negative 64 times 2 all over 4, okay? When we do this, the negative square root of 64 becomes a 8i times 2, so you're going to get negative 8 plus 8i square roots of 2 divided by 4. So, not too hard. Now we can write these out as separate, two separate fractions, or we can factor an 8 out of the numerator, and that 8 will simplify with the 4. Okay, when we do that, So we get 4. You could also factor out a 4 if you want. It really doesn't. You're going to end up with the same thing kind of regardless, okay? It would just be 1/2 in the bottom. So in this case, why are we choosing 4? We're going to factor out a 4 out, so we completely eliminate the denominator. Okay, so 4 over 4 goes to 1, so we're left with -2 plus 2i square roots of 2 with our final answer. Okay. Now, addition and subtraction, very straightforward, very easy. Real numbers with real numbers, complex numbers with imaginary numbers with imaginary numbers. They are complex. So let me start that over. Real numbers with real numbers, imaginary numbers with imaginary numbers. This is when we're dealing with adding or subtracting complex numbers. So notice we have a plus bi plus c plus di. The a and c are the real component. So we can add the a and the c together. The bi and the di are the imaginary component. We can write and combine both of those. Same with the subtraction one below. So let's find each sum or difference here. So if we look at a, we have 3 minus 4i plus -2 plus 6i. Alright, so the real parts here are 3 and -2. The imaginary parts are -4, okay, and 6. Or I could say -4i and 6i. Alright, so the imaginary parts stick together. So when we do this, you're going to get 3 plus a -2, so we end up with 1. Okay, plus, and then we have -4 plus 6, so you're going to end up with 1 plus 2i. Alright, maybe pause the video, see if you can do the next one on your own. Alright, just be careful, you got to distribute that negative. So, reals with reals, complex with, or imaginary with imaginary. Okay, so when we do this one, we have -4 plus 3i minus the quantity of 6 minus 7i. So we got to be careful and distribute that negative through. Alright, so you're going to get -4, okay, plus 3i minus 6 minus 7i. Alright, so when you do this though, and you're looking at this problem going, Mr. Slade, what's going on? Why did it all become, -4 minus 6? We got 3 minus -7. So what we did is we separated the reals with the reals, the imaginaries with the imaginaries. So -4 minus 6, so that negative distributed, okay, that's the real piece. Then we have 3i, okay, minus 7i, but that minus 7i becomes plus because it's minus a minus, right, and the i's on the outside. So we really end up with -10 plus 10i. Alright, so just keep track of that sign when you're doing subtraction. Okay, if we do multiplication of complex numbers, okay, it's just like you did with binomial multiplication. Binomial multiplication. So you can use the FOIL method, or you can use the box method, or whatever method helps you remember that. So it's still just first, outside, inside, last. We're just going to end up having an I squared somewhere that we have to remember to substitute in for a -1 when we do that. And most of the time we're going to get a real plus imaginary, so a complex number when we do this. Alright, so let's find each product here. We have 2 minus 3i times the quantity of 3 plus 4i. So you can go first, outside, inside, last, so you're foiling. Alright. So we end up getting 6 plus 8i minus 9i minus 12i squared. Okay, that I squared has to become -1, so we have -1 times -12, which makes that a positive 12. Okay, when we do that, and then combine like terms, so we're going to have a positive 12, positive 6, it gives us an 18. We had 8i minus 9i, that leaves us with just -1i. Alright, don't get screwed up in part B. Don't say that it's 4 squared plus 3i squared. Do not do that. Okay, that means to take 4 plus 3i times 4 plus 3i. When you're squaring something, it has to multiply by itself. Same rules apply here. You're going to FOIL this out. Alright, so you're going to get first, outside, inside, last. So we end up with 16 plus 24i plus 9i squared. The I squared gets translated into -1. Okay, so you're going to end up with a -9 there. And we're going to combine like terms, so -9 and 16 is a 7, and then plus 24i. So that is a full-on complex number because it has a real part and an imaginary part to it. Alright, lastly, this is the difference one. So what this is going to do is knock out our middle terms, but still it's FOIL, first outside, inside, last are your box method. Alright, but we're going to knock out a negative 30i and a positive 30i if we FOIL all that out. But we really just end up with 6 squared minus 5i squared. Alright, the I squared becomes negative 1. So in this scenario, when we have this, the complex or the number is strictly real. Alright, there's nothing that's left that's imaginary. So notice when we multiply two things that have the same terms but just the opposite signs, so 6 plus 5i and 6 minus 5i, the imaginary piece is going to fall out and we will just be left with the real component of this number. So when we simplify it down, it's 36 plus 25, and that ends up being 61, or we can also write that as 61 plus 0i if you're asked to write it in a complex form. Okay, so make sure that you're paying attention to that. Good news is for you guys, your calculators can do this for you. You just have to do a couple changes to your calculator. Alright, so here's how you put this in your calculator. First, you need to change the mode. So you're going to hit second mode, or just hit the mode button. Sorry, not second mode, but just hit the mode button, and you're going to go down to where you see real will most likely be highlighted. Next to real, you're going to see A plus BI. So you're going to go down and select A plus BI. So now you can do complex mode, and then all you need to do is type in like you normally do. You must use I, and I is located above the period. Very bottom middle row on the calculator there. So you're going to hit second period, and that will put the I on the screen and let your calculator know that you're going to be doing this in complex mode. So yes, it is okay that you will use your calculator, but I do want you to know how to do everything else the other way as well. Alright, so if we have complex conjugates, so remember before when we were doing rationalizing, we talked about conjugates. Same exact thing, only a complex conjugate just means we have a real part and an imaginary part as we multiply these. So in this scenario, we have A plus BI times A minus BI. What's going to happen here is the imaginary parts are going to go away because they're going to cancel. So we're going to be left with A squared plus B squared. Now, you gotta be careful with that B squared though, alright, as it goes through. And the reason it ends up with A squared plus B squared, it really starts out as A squared minus B squared I squared. The I squared becomes negative 1, and since we have minus B squared times negative 1, it becomes plus. So that's how that translates out. Alright, it's A squared plus B squared when we multiply by a complex conjugate, so that we eliminate the imaginary piece. Okay, so we want to write the quotient form. So anytime we're going to do dividing, okay, we're going to multiply by the complex conjugate of whatever's in the denominator. Alright, so we want to write the quotient in the standard form A plus BI. That really means no denominator. Alright, so we're going to take the complex conjugate of the denominator, which would be 5 plus I, that's the complex conjugate, and we're going to multiply the numerator and the denominator by the complex conjugate. That way in the denominator, okay, the imaginary pieces will disappear. So we're going to multiply the numerator and the denominator by the complex conjugate of the denominator, right? So 5 minus I becomes 5 plus I, complex conjugate. So literally just FOIL everything out. I don't think I need to go through all the little steps again. Alright, but you end up with 15 plus 3i plus 10i plus 2i squared. Remember, it only eliminates the complex piece on the bottom, not on the top. Then we have on the denominator, we have 25 minus I squared. That I squared gets translated into negative 1. Same with the one on top. Okay, so when it does that, alright, the bottom becomes 25 minus a negative 1. Alright, so that gives us 26. And on top, we have 2 times negative 1 up there, so you're going to have 15 minus 2, which gives us a 13 for the real, and then you have 3i plus 10i, which gives us 13i for the imaginary piece of that. Alright, so if you wanted to simplify it down, we can factor out a 13 out of the numerator and be left with 1 plus 1i, and then 13 goes into 26, so we end up, really, it's going to be 1 plus 1i divided by 2, and we can write that as 2 separate fractions, breaking each portion out over 2. We have to do that because we want the quotient left in standard form, a plus bi, real plus imaginary, not written as one term. Okay? Alright, so let's do this one. We want to write the quotient in standard form of a plus bi, so that means we got to get rid of the denominator. Well, we have to multiply by the complex conjugate here. So we have 3 divided by I, so we're going to multiply the numerator and the denominator by negative I. Okay, that's its complex conjugate. So when we do that, on top we get negative 3i, on the bottom we get negative I squared. That negative, or the I squared, becomes negative 1. So negative 1 times the negative becomes a positive in the denominator. So we are left with just negative 3i. We can also write it as 0 minus 3i. So we show the standard form and have the real and the imaginary components in our solution. And you can verify your calculator will do it for you as well. Okay? And that way it knows that it's a fraction. Alright, solving a quadratic, this one. Alright, we have 9x squared plus 5 equals 6x. So we get all the variables on one side, set it equal to 0. Alright, so we end up with 9x squared minus 6x plus 5 equals 0. Then we're going to solve the quadratic formula. So we should still remember that's negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Alright, so you're going to substitute in the given values of a, b, and c when you do that. When we do these problems, we know because of the section we're going to be in, we're going to end up with a negative under the square root sign. Okay, so just know that that's what's going to happen. So you guys already know how to do all this piece with the quadratic. It's really that square root of negative 144 becomes 12i. Really no different than what we're doing, and then reduce these 6, 12, and 18 can all reduce down. Alright, if we divide everything out by 6 or factor 6 out of the numerator, it's going to cancel with the 18. The denominator become 3. So we have 1 plus 2i, or we can say it's 1/3 plus 2i and 1/3 minus 2/3 i. Sorry, I'm going to rephrase that because I messed it up. It should be 1/3 plus 2/3 i, or 1/3 minus 2/3 i. Okay, so that's how that should come out when we work through that problem. Alright, we can write it as a solution set. Okay, that's where those funky brackets come in. Alright, and you write it in complex form. Alright, powers of I. We should know that I to the first is I squared is negative 1. We've been dealing with that one. I cubed is negative 1, and I to the fourth is 1. And then the pattern starts all over. It literally goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. And repeats, so on and so forth. So we go through it. Now your calculator will do this one for you. So it's not, super crucial, but we can simplify each power. But what I want you to understand is how we do this if we didn't have a calculator. All right, we have I to the 15th. Well, you're going to write it in terms of, how many I squareds do we have? Because we know we can rewrite I squared as negative 1. All right, so if we know that I to the fourth is 1, we can rewrite some things. So we can rewrite I to the 15th as I to the 12th times I to the third, all right, using the multiplication property of powers. Okay, so we can rewrite I to the 12th as I to the fourth cubed. We know I to the fourth is just a positive 1, so you have 1 cubed times I squared times I. That I squared becomes a negative 1. All right, so our final answer is 1 cubed times negative 1, which gives us negative I. Your calculator will do that for you too. But let's look at b. We have I to the negative 3. Okay, that's going to be really I to the negative 3 times 1 when we rewrite that out. So that ends up giving I to the negative 3 times I to the 4th. Okay, and we know that when we write that out, oops, sorry, I hit the button too fast. When we write that out, we end up getting I to the 4th there, okay? Because why? What is I to the negative 3? Look at the problem above. We just did I to the negative 3, okay? If you go back here, let me go back a slide. I to the negative 3 here, or I to the positive 3, right, is negative 1. So I to the negative 3 has to be positive 1. So that's really where that comes from as we do that calculation there, okay? So I to the negative 3 is a positive 1 times I to the 4th, which is just I to the 4th. We can rewrite I to the 4th as what? I squared times I squared, which is negative 1 times negative 1, which ends up being just 1 when we work that out. Okay? So, alright guys, that's it for this lecture. If you have any questions, feel free. Email me, let me know if I need to Zoom or team call with you. Else guys, ask questions in class. I will have a good day, and I will talk to you soon.